Hey there, viewers, and welcome to space. Thanks for tuning in to our coverage of the closest star on the daily basis. It's just the most comprehensive space weather and detailed solar imagery you'll find anywhere in the world. Coming at you from the Smash News Network, least busted name in news. Here's the past. Well, it's not the past 24 hours. There is still some missing data on the SDO site, so please pay attention to the time and date stamps from all of our custom movies today. These are not 24-hour videos. They usually are, this time not. We've also got a cosmic ray report for you today and plenty more. So strap on your safety belts. It's going to be a sunny ride. So here we've added 131 angstroms. And we've got a little bit of wiping happening there because those images are not synced correctly. Here's 211 angstroms. And we've got a bunch of geomagnetic unrest and storm conditions coming, co-rotating regions, coronal mass ejections, coronal hole high-speed streams, cosmic ray report, and a decent-sized earthquake. Here's just today's imagery. What the heck? I could have sworn I switched it to... All right. Should be just today's imagery. Let's bring up the latest frame. So sunspots have been largely stable here over the past 24. A little bit of growth up here, but pretty stable. Here's your magnetogram from today. Again, no major changes happening there. This might be a place to keep an eye on. And let's talk about what's going on Earth for a quick moment. But first, we are calling on you, the viewer, to help support the channel. Thanks for leaving a comment, Tinman1057, and good morning to you as well. So if you're unable to open your cobweb-encrusted wallet and send us some cash by becoming a member of the Smash team at the gold or silver level, perhaps help us out with clicks. Hit up the homepage, and welcome to the Neo-Renaissance, by the way, smashomash.com. We had to build our own because in 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped from a maximum security social media stockade to the internet underground where we survivors produces a fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. No, you certainly can hire the Smash team. Today's featured product, by the way, is MAXA, which stands for Make Astronomy and Cosmology Science Again. It's part of the channel's purpose. So we figured we would make some great products here featuring the constellation Cygnus in the background, by the way. So MAXA, part of the reason why we make these videos is to make astronomy and cosmology science again. So perhaps pick up one of those and start a conversation with your favorite astronomer, science nerd, or conspiracy theorist. No, we don't think the universe is electric. However, there are some major changes coming to the realm of cosmology. We've been talking about it regularly on the channel, and it's been a long time since we've done a cosmology segment. Maybe we've got to do one. But part of the reason why we study heliophysics in depth is to make astronomy and cosmology science again. So that's one of the major purposes of the channel, so we figured we'd make some graphics to support that. You can find the links below the video to all kinds of things to get involved with our processes. Our Redbubble link below the video in the description will link you to the products in order of best selling. And thanks to everybody who realizes the difference between a scam and a verb. Next, we'll look at volcanoes here, as we're interested in what's erupting and shaken on planet Earth. So let's do a rundown. Shivaluch is producing a 20,000-foot ash plume over Kamchatka, flight level 200. Abiko, south of there on Paramushir Island, also exploding, flight level 100, 10,000-foot ash plume from Abiko. Ibu, also exploding, 6,000-foot ash plume from Ibu. Lewatolo, or Luatolo. Strombolian activity there from Luatolo, and some seismic signals as well. Semaru, flight level 150. It's a 15,000-foot ash plume over the East Javan volcano. Dakono exploding, flight level 070. 7,000-foot ash plume over Halmahera, 22,000-foot ash plume over central Mexico as Popocatépetl explodes. Flight level 220. Flight level 140 over Santiaguito in Guatemala. Flight level 220 over Nevado de Ruiz in Colombia. Sangay and Revenador both exploding in Ecuador. 19,000-foot ash plume and 14,000-foot ash plume respectively. And Sabancaya also exploding in Peru. Flight level 230 to 23,000-foot ash plume. Please do not pole vault the caldera. By the way, that's our best seller in the merch shop. A public service message brought to you at massive personal risk and expense from Smash staff and I here at the Smash News Network, least busted name in news. Next, global seismicity. And we've had some significant earthquakes here. And frankly, we're a little bit overdue for a magnitude 7. So keep in mind, any earthquake can be a foreshock. I feel like a broken record. I say it practically every day. Check out this 6.5, the largest quake of the past 24, occurring there near the Argentinian-Chilean border. In Argentina, it was over 200 kilometers estimated depth there. It came in at 1600 Universal Time yesterday afternoon. And let's run up the rest of the list, citing quakes above a 5 magnitude, of a 5 magnitude or higher. Anyway, there's a 5.1 at Turkmenistan, near the Turkmenistan-Iran border. There was also a 5.5 at the Kermadec Islands, a 5.3 at Argentina. That was a foreshock. See, a perfect example there. So just about 42 minutes later, 5.3, and 42 minutes later, a 6.5. So there you go. Perfect example of a foreshock. Similar depths also, so that's interesting. I'm not sure what that tells us, as this is not really my specialty. Tajikistan also had a 5.9. That was at 20:07 yesterday evening, Universal Time. And then, indeed, Indonesia. Only about 18 minutes later, had a 5.1, 5.6 at the Philippines at 23:31 yesterday evening. Also a 5.7 at Papua New Guinea. Bit of an earthquake uptick here on a global scale. Also West Chile there off the coast. The West Chile rise there near the Antarctican southeast Pacific plate boundary. A 5.2 at the Solomon Islands came in at 5:52 this morning. And let's continue on to get back to space. So some exciting stuff in the forecast here. We've got co-rotating regions and only a minor uptick here in the radio flux. So that was kind of surprising. We were expecting a much more significant uptick in the radio flux. Maybe that's coming, but at the moment, maybe there's plasma in the way. So maybe there's a really dense field of plasma in between the sun and Earth. And some indications are that indeed there is. So there's your 304 angstroms wavelength ionized helium. And again, pay attention to the time and date stamps. These videos are usually 24 hours. Today, not so much. Radio flux is now at 159 solar flux units. There's the 1-year graph to put that in context. Again, surprisingly low here. And frankly, the sunspot number looks low to me as well. So I'm not sure if some sunspots haven't been added to the sunspot number there or what the deal is, but I would expect this to be at least at 130. I mean, it looks like they're missing 50 sunspots to me. That's my story, and I'm sticking to it. Next, Space Weather Enthusiast dashboard, and check it out. We've got some significant activity on the way, and it's got to do with the coronal mass ejection that we forecasted, as well as the coronal hole high-speed stream. So we've got a CIR, which is a co-interacting region. And just to give you a little illustration of what that means, depending on the things like the magnetic orientation of the plasma. So let's say there's a coronal hole high-speed stream coming out, right? If a CME catches up to that, it might interact with it. And when it interacts with it, it might do various different things. In other words, they might combine. You might end up with a thing like this, like a combined coronal mass ejection / coronal hole high-speed stream. You can have the one push the other one, where there's the coronal hole high-speed stream, and when the CME hits it, you get like a bump in this. Also, you can have it pulled out of the way. You can have them add to each other. You can even have them slightly cancel each other out. So there's all kinds of ways that those solar plasma events can interact with each other, and that's what's going on here. Sometimes they amplify each other, sometimes they weaken each other, and so NOAA is forecasting some significant geomagnetic unrest and geomagnetic storms here in the coming days. We've already got some indication that there is a coronal hole high-speed stream already showing up, at least the leading edge of it, the density wave. We'll get to it in a minute. Anyway, there's your forecast expecting geomagnetic storm conditions tonight into tomorrow morning and indeed into the 25th. So let's see, that would be Sunday. So exciting stuff here. The possibility of some aurora at mid-latitudes have emerged through this forecast. Let's take a look at Earth's magnetic moment from space for the past 4 hours. And we do show the Geospace Magnetosphere movies daily on the channel. See some activity happening there in the magnetotail region. Some plasma splashing around there as the slight variations in solar wind happen. Next, we're going to show ground magnetic perturbations, and since we've got some already significant upticks in geomagnetism, we're going to show the North American view. So that's the past 4 hours of ground magnetic perturbations. There we go. There's a significant uptick. The aurora there certainly making it into the U.S. We'll let that play through one more time just to give you an idea of where the aurora are likely. It's raining hard in Lehigh Valley. It's very, very cloudy. There's zero chance that we're able to see it from here. However, if you do pick up any aurora, let us know. Hit us up, especially on Twitter, although Instagram might be another alternative. You can also drop us a line on the Discord chat, which you can find a permanent link to on the homepage at smashomash.com. So here are the global ground magnetic perturbations. Again, this will show you for both hemispheres the most likely places to see aurora, telluric currents, induction into power grids, pipelines, railways, etc. And here, just in the past couple of hours, we've seen a significant uptick in global geomagnetism. So the planetary K-index is currently at 3.66, 3.67. We round. We don't truncate the decimals, folks. We round. 3.67. 3.67 is the current KP index. And you can expect this to uptick, actually, because from what it looks like, at least the last I checked, it looks like the solar wind is going to create some conditions here. So let's see. All right, we've seen a little bit of a weakening of the BZ signal, but we did see the magnetic field strengthen. So let's just take a look at this here for a moment. You can see the white line there. That's the magnetic field itself, making it up there over 10 nanotesla. And then the BZ, which is the vertical component of that magnetic field, well, it's not as negative as it was. So, but that doesn't negate all those forecasts. And this is only the first portion of the coronal hole high-speed stream. We can expect to see this high-density portion drop off, and then we can expect to see a quite high-speed solar wind. So, you can expect to see this drop. You can expect to see the density drop back down to maybe 8 protons per cubic centimeter, and you can expect the speed to come up to 650 kilometers a second. So that's what's going on, plus a CME impact likely early in the day tomorrow. So some exciting stuff there, and we're hoping to see some more aurora here in Pennsylvania. We are located in Lehigh Valley, by the way. Anyway, current conditions are about 21 protons per cubic centimeter for solar wind density, solar wind speed, 485 kilometers per second. And just a quick reminder that those measurements do take place at Lagrangian point 1, well outside of Earth's magnetosphere. It's somewhere around 4 lunar distances. Anyway, GOES magnetometers here showing some spikes as we typically do see with coronal hole high-speed streams, we can also expect to see a dip in the electron flux, which we'll talk about later in the video in our bonus features segment. Next, the heliospheric current sheet. Earth lies in a south pole current sheet. If you bring up the latest frame, you'll see that indeed solidly in a south pole current sheet. However, more importantly, I want you to watch this area right here. So that is some north heliographic polar magnetism of north pole orientation. You can see it wildly moving around there. So that must leave the north heliographic pole before we can, really say that the polar field reversals are going on in earnest. Meanwhile, some south pole magnetism is already up there. And if you look at these green spots that have the lines in them, that means it's at the opposite pole. So, yeah. Some motion there going on, and indeed still quite a bit of magnetism at the north polar heliographic polar region. Check it out. That's a lot of north pole magnetism. That's got to leave and make it to the opposite pole sometime between now and our next solar minimum. So here's our line of sight solar field plot. Polar magnetic fields there in red for south, green for north, and the solar B field depicted in those blue lines, which brings us to coronal holes, which will be the main source of, it's the current source, actually, of the density spike that we're seeing. That is the high-density spike at the leading edge of the coronal hole high-speed stream, showing up maybe a little earlier than expected. And let's take a look at 211 angstroms wavelength from SDO. Oh, seeing some great growth there, actually. You can see this coronal hole spreading out to the east, right there. So a great example of a coronal hole opening up there right on our video. Some serious plasma reorientation, and whoops, that coronal hole grew, which actually could extend the amount of time that the Earth sees geomagnetic effects, as that is happening right near the equator. Next, we'll move to sunspots. I've heard people say that they're important for solar cycles, so let's cover it, shall we? So there's what's going on. I think we've got some new groups to be named up here in the north. Not 100% sure of that, but besides that, it's mostly stable here for the past 24 hours. Let's show some videos. There's what we could get for the past 24 hours. Let's get in a little bit closer here. At least one new sunspot might get named up here. I'm not sure if this is considered a new group also. Let me go back here. I think we can expect at least one or two more named groups today. And I don't think the sunspot number is right. I think the sunspot number is way too low. Keep in mind, every individual umbra that you see there counts as like 6 as far as the counting. It's a little odd. And keep in mind, part of the reason that the counting is sort of weird for sunspots is that we have to find a way to attempt to tie today's extremely detailed data together with data that's hundreds of years old, because people have been counting sunspots for hundreds of years. Anyway, here are our magnetic fields also. Again, things fairly stable over the past 24 hours. And let's talk about energetic particles and solar flares, which have been mild as well. So proton flux here just making its way back down. Excuse me. Making its way back down to the zero line there. No spikes in the proton flux. No major flares. In fact, the flaring has dropped off a cliff as well. So, check it out. We're down below a C-class background X-ray output there. So, yeah, another dip in the X-ray flux, even though a bunch of sunspots are sort of moving closer and closer to the directly Earth-facing zone. Here's our 94 angstroms wavelength for the most of the past 24 hours that we could get. Likelihood of large flares is still there, folks. These sunspots that we see on the Earth-facing portion of the solar disk are magnetically complex. Here we've added 131 angstroms to the 94. And let's step back and consider what's going on overhead. Now, we're located in Lehigh Valley, Pennsylvania. So we've created a star chart for what's going on over us. If you want to make your own, head to skyandtelescope.org. You can make a star chart that looks just like mine. So that's what's going on. It is pre-sunrise, and if you're up before dawn and you've got clear skies, you might be able to see Saturn. And speaking of planets, let's do a solar system forecast. Here's where things are now. We hope you enjoyed New Moon and got some great sleep. Here's where things will be in 1 week. I'm sorry, that was 8 days. I can't count to 7. I didn't know it was going to be so hard to do this. I got to count to 7, folks. There's where things will be on the 30th of March. We will have a gibbous waxing moon, and the Earth will be in a very lonely side of the solar system, lacking planets in general. And zero terrestrial planets and zero gas giants, although Mercury and Venus are making their way around. Next, we'll look at coronagraphs. And coronal mass ejections have been pretty chill in the past 24 hours as well. That's yesterday's imagery from George Mason University. Here are 14 more frames from today. Let's take a look at Stereo A's imagery as well, and Soho Lasco C3. Please pay attention to the time and date stamps at the bottom. And again, it's been very light as far as coronal mass ejections the past 24 hours. Only a few quite minor events. And we don't suspect any of those are earthly directed. So here are some movies that are going to show you how much missing data is from the SDO. Because you're going to see the SDO imagery freeze up and jump around there. That's Mercury, by the way, on your left. And these are approximately 24-hour videos. Again, time and date stamps in the lower left. So some minor CMEs, likelihood of CMEs is fairly high here. We do have a very, very large filament in the northern hemisphere. You can see it there in the 304 angstroms wavelength. We'll show you some extreme close-ups of that here before we get to our bonus features segment and our meteorology portion. So here are the filaments. This is the hydrogen alpha imagery from El Teide, Spain's ground-based solar observatory. We do have some massive filaments in the Earth-facing portion of the solar disk. We also have some major sunspots that are magnetically complex. And if you want to name filaments, make sure you follow the hashtag Name That Filament over at Twitter. If you'd like to try out the free mushroom gummies from Hemp Lucid, check those out. Here's what you'll get. And we actually made a video yesterday. We're waiting for it to be remonetized to release it to YouTube. So here's, this is the wavelengths that we like to use to show filaments. 193 plus 304 angstroms. Behold the filamentary gorgeousness of the closest star, El Sol, aka Helios. And let's get a little closer to that filament up there, which does not have an STD. However, it is named the Gene Simmons filament. Again, if you want to name filaments, follow us over on Twitter at twitter.com/smashamash. Follow the hashtag spaceweather, hashtag spacewx, and the hashtag namethatfilament. So that is a gigantic filament. You can see the Earth scale there. What is that? 50 Earths in diameter, 50 Earths in length or something like that. We can't even really see the northeastern anchor point, although it does look like it's anchored somewhere around here. Can't say for sure. How about an even closer view? That filament looks just like Gene Simmons' unibrow. Anyway, just spectacular imagery there. And thanks for leaving comments, Mike Bordages. I don't know what you're congratulating me on, but thanks. All right, so here's 304 angstroms once again, and let's get rid of that and move on to our last couple of hours here from the GOES 16 SUVi. There is some action happening right around here, right in the Earth-facing portion of the solar disk, just south of the equator. So that could be the source of some activity today. We'll be keeping an eye on that. And this brings us to our bonus features segment. By the way, if you do want to name some filaments, we've got a prominence down here, we've got a prominence over here, a prominence up here. Those are all nameable filaments. Name them after living people over on Twitter. And we will make sure that filaments get named as per your instructions. So we're starting out with bonus features here. Charging hazards are existent here at the moment. Surface charging hazards happening over Mexico especially, also the Caribbean, northern South America, and the eastern Pacific. Electron flux here is actually a little higher than we expected, but we can expect to see this dip precipitously. We'll see if NOAA agrees. That's the 3-day GOES 16 and GOES 18 radiographic measurements to determine electron flux at the F layer of the ionosphere. And here I've got to strongly disagree. We're going to see this drop way down. So that NOAA forecast, unlikely to be correct. You can verify tomorrow whether or not I was right. There's the 1-year graph to put it in context. Again, we are expecting to see this dip down with coronal holes and coronal mass ejection impacts. Next, the F layer of the ionosphere. It's at 300 kilometers of altitude, and here's the vibrational frequency there. This data is courtesy of Australian Government Bureau of Meteorology. If you're not familiar with looking at it, don't worry. We've got the anomaly gram as well. We certainly see some high-frequency anomalies. The low-frequency anomalies might be a little bit harder to get a bead on. Certainly some of both, especially surrounding the South Atlantic anomaly, which will be more obvious when we show the anomaly gram. So the South Atlantic anomaly is right about where my pointer is. You can see the wild variations there in the vibrational frequency of the ionosphere. Right there. And we do indeed see some significant low-frequency anomalies happening over places like North America, northeastern Asia, also northern South America, Central America, some low-frequency anomalies happening. Let's bring up the latest image. There's 1045 universal time ionogram and 1045 universal time anomalygram. That's anomaly in megahertz from a 30-day median. And before we get to the latest high-res imagery, how about the total electron content? That's the free electrons between your GPS satellite and your handset, a run of about 12,500 miles. And we can expect to see some more significant anomalies here as this coronal hole strikes. Check it out. We've got some low electron anomalies over Central South America. So that's not one you see every day. That's a little bit anomalous. And let's talk about North America. There's the anomaly over North America. That's the difference from the 10-day average. Oh, some big variations happening there over North America. Let's let that play through one more time. A sudden dip in electron content right there. So that was certainly interesting. Let me bring that back. So a big dip in the electron flux happening there late last night around 22:15. And that should be reflected here as well. That's just the US map, basically just a zoom in of the same data. So some low electron anomalies over the Americas. All right, we're almost at meteorology. First, some high-res imagery of El Sol. And what do we have going on up here? That's not a sunspot, but that is. So that one's not named yet. That one might get a name. Is it magnetically complex? Well, not really. That looks like more than one sunspot to me. Let us know in the comments what you think. I think that's probably actually two sunspots, but ultimately it doesn't really affect the sunspot number because of the way the umbrae are counted individually anyway. So whatever, I don't get hung up on the names. We hope you don't either. These groups down here look like they are slowly degrading. And that is another sunspot group there in the southeast. So this one here, I think that's a second group. Oh yeah, that's a second sunspot. Because right here you've got South Pole polarity, that's an alpha class, and then a second smaller alpha class sunspot trailing. So that sunspot there ought to get a name. So again, we may see a minor uptick in the sunspot number again today. It still seems very low based on especially the amount of umbrae that are in this area. I mean, look at all those dark spots. Yeah, those sunspots have been degrading a little bit for the past couple of days. There's your full disk rock back. And before we get to meteorology, one last thing, cosmic ray report. So here is the, let's see, that is a, that's DOMB Antarctica's. And a small downtick in the past 30 days at DOMB Antarctica. DOMC Antarctica showing a very similar graph, a slight downtick over the past 30 days. Oulu, Finland. Oulu's neutron monitor there showing a slight downtick in the past 30 days as well, a very similar graph. And let's go way down south to the land of Mexico. There's Mexico City's Cosmic Ray Observatory. And an uptick over the past 30 days at Mexico City. I find that interesting. What about you? Let us know in the comments. How about Athens, Greece? Going a little bit farther north and across the pond. There's the Athens neutron monitor. Showing almost flat levels there. Very close to flat levels. Not really an uptick or a downtick. Maybe a tiny downtick. It's a tiny downtick, folks. And let's also go way back up north to Apatity and Barentsburg. So let's see. First Apatity, tiny downtick at Apatity, almost flat. And Barentsburg, a slightly larger downtick in cosmic ray flux over the past 30 days. That's your cosmic ray report. And before we get to meteorology, just a quick note. You can find links to the Hemp Lucid shop below the video. So perhaps improve your health, sleep, focus, etc., your immune health. All kinds of different solutions can be reached with Hemp Lucid's fantastic products. The most popular is the water-soluble CBD tincture, but there's a lot more than that. CBD lip balm, CBD body balm, and all kinds of other fantastic stuff. Who knew how good these products were? Well, we didn't until we became an affiliate, and we are stoked about it. So visit the link below the video or enter the promo code SMASHOMASH. The promo code SMASHOMASH to save some dough on your checkout. Once again, if you want to support the channel, consider becoming a member of the Smash Team at smashomash.com/Smash Team. It's our own subscription services site. We launched it back in October of 2021 because we needed additional capabilities that Patreon didn't have. We are still on Patreon, though. If you want to support us that way, feel free. And thanks to everybody who has contributed to the possibility that these videos will continue to exist, remain publicly visible, and free for all to view. We are also writing a paper to explain plausibly the sunspot cycles. And one last one last thing, another perk of being a gold member of the Smash team is that you can get your very own at smashomash.com email address. We will hook you up if you'd like, I don't know, Bill at smashomash.com. We've got you covered if you join at the gold membership level. So thanks again to everybody who has. Let's get to meteorology. We're starting out by doing some wave chasing. So here we go. These are the largest waves in the world, at least when we did show prep they were. 31 footers there, right around the Atlantic/Southern Ocean boundary. A couple thousand miles there to the west of the Drake Passage. Should be the world's largest waves there, 31.2 footers. Only 28 footers there, south of Iceland. Anyway, the animation is showing the surface winds, so let's do that and blast through our meteorology segment. So these are the surface winds of the eastern world. We show them daily on the channel to help people understand global weather patterns. And thanks for leaving a comment, Robert LaFollette. Next, jet streams of the eastern world depicted here. Jet streams of the west. Surface winds of the west. Surface winds of Europe, Africa, and the Middle East. And jet streams. Next, clouds and fog over the Americas. That's 3.9 nanometer infrared radiation from our NASA GOES Interactive Weather Satellite Suite. If you're trying to look for the aurora, the 3.9 nanometer infrared radiation map might help you out, as you'll be able to tell whether it's cloudy at nighttime. Although you could just go out and look up. Depends on how lazy you are. So here's our weather.gov map. If your location's lit, click your location. There's a lot of flooding forecast for Ohio, West Virginia, Indiana, Kentucky, Illinois, Missouri, Arkansas, and Oklahoma. We're scrolling down to show you the key here for a moment. Weather.gov is the location. If your location is lit, click your location. Special marine warning there at Hawaii. Not sure what that is, and it's too much for us to cover, so let's move on. A bunch of avalanche warnings happening there in Colorado. Remember, folks, don't be underneath large shelves of snow, especially with all the hot air that is constantly billowing out of Colorado. Here comes some forecast. This is your positive accumulated snow depth change forecast. It is in inches. And check it out, Oregon is in the crosshairs for some major snow there. 2 feet coming to large swaths of the state of Oregon. That's a 72-hour GFS forecast model. And here's a 72-hour GFS forecast model for pressure and precipitation. Again, like we said yesterday, there are some strong storms coming to especially Missouri, Illinois, and Indiana. Please see the map for further details. That's pressure and precipitation for the next 72 hours on the GFS model. Here's total accumulated precipitation in inches on the same model. And you can see, again, like we said yesterday, expecting 6 inches of rain for portions there of Missouri, Illinois, Indiana. That's a lot of rain, so be prepared for that. Please don't drive through moving water. Unless you know the depth, then it's on you. So another feature of Windy.com here is the check globe portion. So this is pretty sweet. You can look up drought intensity. You can look up soil moisture. But what we've brought up here is soil moisture anomaly. So I find that interesting. You can see that soil is shockingly dry here in places like North Carolina, Virginia, Maryland, and Delaware. Also Kansas, featuring quite dry soil there, about 2.3 inches behind their average rainfall. Meanwhile, California, Arizona, New Mexico, Nevada, Utah, Wyoming, the Dakotas, Minnesota, parts of Oklahoma, Quite moist indeed. Quite moist indeed. Check out the windy.com mobile app if you like. It's got all kinds of sweet features. It is free, and we are not yet paid to endorse windy.com. So here's our lightning mapper. And things have been pretty chill, but we've actually got some lightning storms now. So California saw some lightning in the past 10 hours. And let's check our real-time lightning map. So we'll briefly zoom out here. There's the full world view. Some lightning happening there by Hawaii. Was that just one bolt? One bolt off the coast of Kauai. Anyway, it looks like we may have some active cells in the U.S. What do we got? Some thunderstorms happening there near Savage River State Forest. Sounds lovely. Anyway, hopefully your river's not too savage. Although your rivers might become savage when all the snow melts following our 7th consecutive winter of record snow in the Northern Hemisphere. Next, U.S. Doppler radar. Some showers there around Alaska and some heavier precipitation there around Hawaii. We're going to focus on the lower 48 and close this mother out. There's what's going on. A bunch of moisture there, mainly around the Great Lakes. Clouds and fog are looking like this. It's a bad day to look for the aurora over Pennsylvania. And there is water vapor. All the water here being channeled through in between some drier, more massive air. That's an atmospheric creek. Not to be confused with an atmospheric lake, pond, or ocean. Or, of course, the ever-popularly stated atmospheric river, something featured on countless YouTube thumbnails and titles. Anyway, here's your recap. Hopefully it didn't frighten you too much. Hopefully you're prepared to go out and take videos of the aurora in the coming days. We're super excited about that. We'll have multiple cameras ready to capture it. There is clouds and fog one last time, and there is water vapor. So, hey, everybody. Once again, thanks for tuning into the Smash News Network, least busted name in news. Make sure you support the channel. Thanks to everybody who has, the past 5+ years. We're pushing 6 years of daily space weather videos, missing only about 3 or 4 days in that entire period of time. In the meantime, thanks for tuning in. And may that solar wind be at your back. Also, don't forget to visit the links over here and so on.